Right now, deep in the Himalayas, China is building a dam so large it will generate 3 times the power of the Three Gorges Dam. The structure so massive, it measurably slowed the rotation of the Earth. And here's the part that should stop you. The engineers building it are using techniques that did not exist when they were born, solving problems that had no solutions 20 years ago, working at altitudes, in terrain, and at a scale that no engineering textbook on Earth had ever described. That is exactly what this video is about. 10 things China has built so big, so far beyond precedent, that the people designing them had to invent the engineering as they went. Number 1. The Motuo hydropower station. In July 2025, China broke ground on what will be the largest construction project in human history. A cascade of 5 dams on the Yarlung Tsangpo River in Tibet, costing $153 billion. When complete, it will generate 300 billion kilowatt hours of electricity every year. That is nearly 3 times the output of the Three Gorges Dam, and roughly equal to the entire annual electricity consumption of the United Kingdom. From one project. To build it, engineers are working at altitudes above 10,000 feet, in one of the most seismically active regions on the planet, boring 4 separate 20-kilometer tunnels through Namcha Barwa Mountain to divert part of the river through a 2,000-meter vertical drop. There is no precedent for this. No engineering manual describes how to build at this altitude, in this terrain, at this scale. The engineers are inventing the methods as they go. Number 2. The Fast Radio Telescope. 500 meters across. The largest single-dish radio telescope on Earth. Built into a natural bowl-shaped depression in the mountains of Guizhou Province, with 4,450 individual aluminum panels that move and adjust in real time to focus on different points in the sky. It can detect radio signals from across the observable universe. When it was completed in 2016, it was so far beyond any previous telescope that the engineers had to develop entirely new techniques for building and calibrating a structure that size with that level of precision. Number 3. The high-speed rail network. 46,000 kilometers of high-speed rail. To put that in perspective, the United States has 0 kilometers of true high-speed rail. Not less than China. 0. China's network is longer than the rest of the world's high-speed rail combined. In the first half of 2025 alone, it carried 2.24 billion passenger journeys. The network crosses rivers, mountains, and valleys almost continuously, which means it is not really one project. It is thousands of bridges, thousands of tunnels, thousands of viaducts, all engineered and built within a single generation. And here's the detail that connects all 3. The Three Gorges Dam, completed in 2003, was the project that first required China to mobilize engineering talent at a scale it had never attempted before. The engineers who learned to build it trained the next generation, who built the rail network, who trained the generation now building Motuo. Each megaproject is a school, and each graduating class is larger than the last. This is what 10 times the engineers actually produces. Not just more projects, but a compounding chain of expertise that the rest of the world cannot replicate without first having the people. Number 4. The bridges. China is home to the overwhelming majority of the world's tallest and longest bridges. The Duge Bridge stands 565 meters above the river below it, the height of a 200-story building. The Danyang Kunshan Grand Bridge runs for 165 kilometers, making it the longest bridge ever built. China builds these so routinely that a structure which would be a national engineering landmark in any Western country is, in China, simply another piece of infrastructure that needed to exist for a rail line to cross a valley. The engineering that goes into a single one of these bridges would have been considered the pinnacle of human achievement 50 years ago. China completes several per year. Number 5. The automated ports. The port of Shanghai is the busiest in the world, and large sections of it now operate with almost no human beings present. Driverless cranes, autonomous container trucks that navigate by themselves, AI systems coordinating the movement of millions of containers. The engineering challenge here is not steel and concrete. It is software, sensors, and systems integration at a scale no Western port has matched. The engineers building these ports are not civil engineers in the traditional sense. They are systems engineers, software engineers, robotics engineers, disciplines that barely existed as career paths when the previous generation of port infrastructure was built. Number 6. The ultra-high voltage power grid. China has built the most advanced long-distance electricity transmission network on Earth. Ultra-high voltage lines that carry power across thousands of kilometers from the dams and solar farms of the West to the cities of the East, with minimal energy loss. This is the technology that makes the Motuo Dam useful, because a dam in remote Tibet is worthless unless you can move its electricity to where people actually live. The west-to-east power transmission strategy required China to solve engineering problems in high-voltage physics that most countries had not even attempted. China now leads the world in this technology and exports it. Notice the pattern forming. These are not isolated achievements. The dam needs the grid. The grid needs the bridges to carry transmission towers across terrain. The rail needs the bridges to cross valleys. Each project requires the others, which means they all have to be built at the same time, which requires an engineering workforce deep enough to run all of them simultaneously. A country with 130,000 new engineers a year picks one or two of these and takes decades. A country with 1.3 million runs all of them at once. Number 7. The Tiangong Space Station. China built and operates its own space station entirely independently after being excluded from the International Space Station program. Tiangong orbits the Earth right now, permanently crewed, conducting hundreds of scientific experiments. Building a space station from scratch as a single nation is something only 3 political entities in history have ever achieved: the Soviet Union, the United States working with international partners, and China alone. The engineering workforce required to design, launch, assemble, and operate a crewed orbital laboratory is staggering. China assembled that workforce in a single generation. Number 8. The East Fusion Reactor. The experimental advanced superconducting tokamak, China's primary fusion research device. In 2026, it crossed a threshold no previous fusion experiment had reached, sustaining plasma at the conditions needed for fusion energy for longer than any attempt in history, and pushing past what physicists call the Greenwald limit for plasma stability. Fusion is the hardest engineering problem humanity has ever attempted, recreating the process that powers the sun inside a machine on Earth. China is investing in it at a scale very few countries can match, with the engineering workforce to staff it. Number 9. The JUNO Neutrino Observatory. 700 meters underground in Guangdong Province sits the largest neutrino detector ever built, a 20,000-ton sphere of liquid scintillator designed to capture the most elusive particles in the universe. In June 2026, it delivered its first major scientific result, one of the most precise measurements of neutrino behavior ever achieved. This is engineering in service of pure physics, built underground, at a scale and precision that places China at the frontier of fundamental science, not just applied infrastructure. Number 10. The digital infrastructure. 4.8 million 5G base stations, nearly 7 times what China had in 2020. A national program called East Data West Computing that coordinates data centers across 8 major clusters. China built the largest, fastest, most comprehensive digital infrastructure network on the planet, and it did it in years, not decades. The engineers who built this did not exist as a profession when the previous generation of telecommunications was designed. 5G engineering, large-scale data center architecture, AI infrastructure, these are disciplines that were created within the careers of the people now practicing them. 10 projects, every one of them at or beyond the frontier of what was previously thought possible. And every one of them is a downstream consequence of a single upstream decision China made 30 years ago, to train engineers at a scale no other country was willing to match. Now here is where most videos on this topic stop being honest with you, and I want to be different. More engineers does not automatically mean better engineers. This is the strongest argument China's critics make, and they are not wrong to make it. Wang Hong, president of the China-Europe International Business School, said it directly. China's talent pool, in his words, is large in number but not strong enough in key technology and basic research areas. The quality of the average Chinese engineering graduate varies more than in the United States. Roughly 45% of China's STEM PhDs come from its elite double first-class universities. The other 55% come from institutions where standards are less consistent. The United States produces fewer engineers, but they emerge from a more uniformly rigorous research environment, and American research still leads the world in citation impact, the measure of which research actually changes a field. There is also immigration. For decades, the United States imported the best engineers in the world, including many of China's own top graduates who studied in America and stayed. These are real points. But here is what they miss. Quality at the margin does not build a $153 billion dam in the Himalayas. Scale does. A megaproject does not need the single best engineer in the world. It needs 10,000 competent engineers working in coordination at the same time on the same impossible problem. The Motuo Dam does not care whether the average Chinese engineering graduate publishes slightly fewer citations than an American one. It cares whether China can put enough trained minds at altitude, in seismic terrain, boring tunnels through a mountain, all at once. And on that question, the 10-to-1 ratio is decisive. Meanwhile, look at the other side. In the United States, the American Society of Civil Engineers reports that nearly 30% of civil engineers are over the age of 55. Roughly 1.7 million infrastructure workers will leave their jobs every year through 2031. Engineering firms are turning down work because they cannot find people. Individual American states have started offering tax credits to attract individual engineers. China graduates 1.3 million per year. One American state is offering $5,000 in tax credits to hire one engineer at a time. The two countries are moving in opposite directions. And that gap took 30 years to create, which means it will take at least 30 years to close, even if America started today, which it has not. There is a detail in this story that almost nobody talks about. When the Three Gorges Dam was completed in 2003, it was so massive that it measurably slowed the rotation of the Earth. The engineers who built it were, at the time, attempting the largest construction project humanity had ever seen. Many of them had been trained in the 1980s and 1990s, in a China that was still poor, still developing, still decades behind the West in almost every measure of industrial capability. Those engineers trained the next generation. Who built the rail network and the bridges and the ports? Who are now training the generation building Motuo and Tiangong and the fusion reactor and the Neutrino Observatory. Each cohort larger than the last. Each one inheriting the knowledge of the one before and pushing it further. That is the thing the 10-to-1 ratio actually buys. Not just more projects, a compounding engine of human expertise that grows every single year and that no amount of money can shortcut, because you cannot buy 30 years of trained engineers. You can only grow them. China started growing them 30 years ago. The results are now rising out of the ground, in the mountains, in orbit, and underground, all at once. And the engineers building them are using techniques that did not exist when they were born, because they are the ones inventing them. If this video changed how you understand what China is actually building and why, hit like and subscribe. We cover every major development in Chinese technology and infrastructure as it happens. And here is a question for the comments. If it takes 30 years to train an engineering workforce, and China started 30 years ago, is there anything the West can do now to catch up? Or is this gap already permanent? Drop your answer below. We read every single one.